It's about maximizing business potential, enabling research and innovation at the university. By accelerating commercialization through global collaboration, fast and innovative in the way we do business with our partners, while, of course, protecting our assets and the researchers' needs. So it's really about this wheel that you see here, in which we create, or our great researchers create research and innovations, and we protect the IP. Then we help in incubation and mentoring, and bring funding, which then funds more research and innovation. What we really want to do is to make sure that this wheel spins much faster and much stronger. The University of Haifa, with its 18,000 students and its great multicultural spirit, has excellent areas of excellence in its research. I have selected here just a few that are more related to our sources of innovation in terms of commercialization. So the first is the Tauber Bioinformatics Research Center with Professor Leonid Brodsky, doing great research in the area of bioinformatics, which is a very significantly growing area today. Then the Department of Geography and Environmental Studies, Computer Sciences and Information System departments. We will talk about some exciting collaborations that we are going to have in this area. Then the Neurology department. It's already a source of great innovation, part of our companies that we'll mention shortly. The Evolution Institution, and then Natural Sciences faculty. Very strong team, very innovative. The Safra Brain Research Center and Education faculty. The Public Health School, that now, with the collaboration with Rambam, will become even more significant in our collaborations with Rambam and with others. And then, of course, the Marine Sciences School, one of our jewels. It's a very exciting team with great technologies, the best in Israel, and we create many innovations from this team. So when I joined Carmel 4 years ago, my friends asked me if I will have enough to commercialize at the university. And while my answer was certainly yes, it was very evident to me that first it will be a challenge, which I really like, and second, we can't just continue and do more of the same. We need a game changer. We need to do it differently. So what do we do in Carmel? We manage all the intellectual property of the university. We do license agreements with various parties. We are trying to get as many governmental funds to fund research, together with our researchers, of course. We collaborate with global industrial partners and academic partners. We are trying to be as proactive as we can in getting more and more of these partnerships. And we do interinstitutional research and commercialization agreement with our partners around. So we do similar activities maybe to other technology transfer companies, but we are trying to be as business-oriented, as fast, as proactive as we can, and to become the first choice of the leading companies and partners. At the same time, we are also focusing on entrepreneurship, on spin-off companies, trying to create at the university an entrepreneurial culture, trying to create some role models that will then affect others. We are dealing with incubation, with mentoring. We are assisting the companies that we establish in growing. And we manage funds that we will talk about in a moment, investing in university projects. So as part of our goal to be fast and easy to work with, we have increased significantly the number of partners that we work with. You may see here in the list various areas, various companies, defense industries, Rafael and others, the electrical company of Israel, pharma companies like Merck, J&J, and others, Samsung, banks, police, just name it. And this is just a partial list. And we are trying to be as easy for them, as fast as we can, and proactive. Another major activity that we deal with is funding from the government. We have increased dramatically the amount that we get from the government in our various projects. In fact, it increased in 9x. And you may see in this list various projects, various partners, various areas. So it starts with chip inspection, media consumption, social media, some projects about preterm infants, big data video, and others. Some more projects. And this is the part that I'm very excited about, my baby. Where, as we said at the beginning, it was very clear that we need a game changer. When I was a partner in the venture capital firm, I kept telling my friends at the universities that their projects are too early. And that's what I heard when I came to Haifa, of course. It's too early. But then the challenge is that on one end, it's too early, and on the other end, it's too late to get some grants for innovative research because it's kind of more mature. So here is the gap. And the question is, how do you fill in this gap? And that's part of the challenge in most of the universities. So we established Carmel Innovation Fund. And this is really a game changer. We'll talk about the fund, but first, I couldn't have done it without my great investors and board members, Professor Milgrom and Mr. Amir Milgrom that are here, Professor Tauber, Mr. Mick Davis that couldn't join us. Today they have elections, right? And the Everwater group, represented by Orit and by Erez. Thank you. So what is it all about in the fund? So the fund is an evergreen micro fund, a small fund, intentionally small fund. We are trying to be flexible and with great potential. Carmel holds 30% in the fund, our investors hold 70%. Investors nominate board members, and they influence the project selection. Unlike other VCs, we don't just get the money, and they can pray and wait. They are involved. Some of our board members visit our projects even monthly. They are part of the project development. They are providing advice, and they are very much involved. We also have a special model for donations and investments. The seed investment in these companies is up to $700,000 per project. It might not be a lot, but you will see that it's quite enough to bridge this gap. The fund holds up to 75% in the established company, and we hold 25%, so in total we hold 50% in the company through the fund and directly. We are assigning our patents irrevocably, exclusively to the companies, and part of the model is that we continue to get royalties from these companies after the establishment once they have revenues. Investors have the right to invest directly in the portfolio companies in addition to investing in the fund, which is a huge advantage. They know the companies very closely. They can select which ones they want to participate in. And the companies are expected to reach significant milestones within 2 years from the establishment. So the goal is to get a strategic agreement or maybe M&A with a potential 7 to 10x return within quite a short period. For our investors, it's certainly a risk reduction, being able to split the risk between several investments through our fund. So in a very short time, we succeeded to establish the fund and to establish 6 companies in the fund. Rescue Pharma in the area of cancer treatment, we'll talk about it. Memofit in the area of Alzheimer's and MCI. Artsavit, fighting cancer. Memodero, PTSD. MemoBoost, learning improvements. And CanCure in the area of cancer. And the good news, the exciting news, are that in a very short period, we succeeded to have 2 successes. One is Memofit, the second is Artsavit. Memofit, as I said, it's in the area of Alzheimer's. We succeeded within a year since inception to get $8 million from J&J, Takeda, OrbiMed, and FutureX, and with a very significant valuation increase for our investors in Carmel Innovations. And it was certainly a recognition for our project quality by global companies that didn't even visit Haifa before this collaboration. And we maintain, as Carmel and Carmel Innovation board memberships and a significant holding in the company. And then Artsavit, we raised $6.3 million 2 years after the establishment of the company, with a valuation increase of 6.5x, and we succeeded to grab the attention and partner with Merck Ventures, Arking BioVentures, and Pontifax. Strong teams in this area, very powerful and very helpful. And again, we succeeded to maintain a significant share in the company following this investment. So the model works. We see that with this small fund from the fund, funding from the fund, we succeeded to bridge the gap, to bring in partners that prior to that, they just told us that it's too early. They didn't even visit us. And then they thought they are interested enough, and it's worth, and it's the time to join. And it works for our investors, as we said, in terms of the valuation increase. For the researchers, it enables the continuation of the research, and for the society, because otherwise these projects have been here, continuing to be here in the university with no progress. So all these activities and proactive activities led to a significant increase in the funds that we succeed to bring through our activities. So while in the 4 years before I joined, we had less than $5 million in the funds raised through our activities, it grew 10 times to almost $50 million. And thank you. And now, a surprise. It's even a surprise to my board members because it happened just in the last few days. I'm very excited to announce that we are launching today Carmel Innovations 2. Thanks to our investors that with their vote of confidence, they confirmed in the last few days that they are going to participate in this fund. And I'm sure we will do our best not to disappoint them. So what will we have in Carmel Innovations 2? First, it will be a diversified fund. It will not deal just with biotech. It will be biotech, IT, marine technologies, artificial intelligence, big data, digital health. It will be an evergreen fund. Very important. That's how Fund 1 is as well. We are not limited to 8 years or 10 years as other VCs. We can decide, the board and the investors can decide whenever they wish to share dividends or to share the revenues. Again, they have the right, the investors have the right to invest in projects from the university. They will nominate board members and influence the selection. So what are the fund's advantages? So first, it has first access to university-based projects and companies, leveraging all the years of investment by the university, the grants that we received, all the hard work of our researchers. And then our leading researchers, the best of all, continue to be part of these companies, to support the companies, to lead their research. It's their baby. And And then we have a very strong link to strategic partners, as you could see. I have been there with them in the past. I know how they think. They are coming on, and we could see in the two examples that I shared with you. We have a very strong advisory board that helps us in our decision-making. Most of the projects that I bring to the fund are projects that I first heard from the strategic partners that they can be interesting. Yes, too early, but if we will make progress, they will be interesting enough. Investors have also the right to invest directly in the portfolio companies, and we as Carmel are providing incubating services, finance, legal, business development. We let our researchers focus on advancing the research, and we do all the rest. And of course, risk reduction, because we invest in multiple projects in various stages. So what's the business model? First of all, the fund will be able to invest in follow-up investments in companies from Fund 1. They are a little bit more mature, which is certainly an advantage. And then for new projects, again, around $500K in each selected promising projects. We'll try to reach significant milestones within 2 years, try to get a strategic agreement in this period, and exit proceeds will be distributed based on the fund board decision. And it's open for additional new investors. I'm here in the break. You can line up. So in addition to the companies that we have in Carmel Innovations, we have established additional companies, one of which is Pine Biotech, based on the excellent research of Professor Leonid Brodsky. By the way, you will also be later in one of the stands outside, and you are invited to hear more. So it's about a platform for bioinformatics analysis for various applications. It ranges from validation of polio diseases, cancer diseases studies, personalized medicine, ecological projects and various types, education. It can be very beneficial for education, and many other different industry collaborations. Bioinformatics is an area that I'm personally very excited about. It's an area that is growing very significantly, and we are very optimistic about this company. We have already created several partnerships with significant partners like Mayo Clinic and UCSF and others. Another company is Spalax, based on the research of Professor Avivi, Professor Manov, and Dr. Shams. And this is a very interesting story. So, while a regular mouse lives for 2 years, and a rat lives for 2 to 3.5 years, the Spalax, the blind mole rat, lives more than 30 years. Yes, he lives most of the time under the ground, which might be not too exciting, but he doesn't suffer from cancer, he doesn't suffer from any aging diseases. So high quality life. And what the team did is, the team was trying to study what is it there that provides this opportunity or these properties for long and high quality life. And they have identified proteins that can be used for various therapeutic applications, like cancer, like diabetes, like cardiology. Very exciting. Yes, still early, but they will get there. We are raising funds for this one as well. Mr. Peter Kadas invested in this company a very significant amount. He strongly believes in that. He's a great supporter of our university, and hopefully we will succeed. So in addition to the companies and the fund and our partnerships with global partners, we had a strong focus in the last year with China. Working closely with our president, Ron Robin, with Professor Ido Itzhaki, and with Lily and others in the university, we are establishing a collaboration with Wahaha, a leading beverages company. In fact, the founder and the CEO of this company is the number 8 billionaire in China. He came to Haifa. He was very excited about what we showed him here. Then we visited him, and we signed an LOI as part of the innovation meeting with Bibi Netanyahu in China. Wahaha is looking to invest $10 million in a joint institution that will be established in Haifa, hopefully in the industrial park. Where is Shmuel Gantz? In this industrial park, we are looking to increase our collaboration with the Haifa Economic Company. They might become part of our fund in the future. And we are also looking to collaborate and to establish, together with Shanghai businessmen, a fund of $5 million that will invest in projects from the university. So let's look into how we can frame our collaboration and partnership model based on all I've told you. So we have two ways to do that. One way is to establish a subsidiary, a direct subsidiary with investors. We will always do it when we will have investors. And then we get equity, we get royalties for our patents, board directorships, incubation. We provide incubation services. We continue to do research at the university, at least for part of the research, which is very important. And we share the IP. Another way is to do it through our fund. And then we have equity in the fund. We have board directors in the fund. We provide services to the fund. And when the fund invests in the company, we still have all these abilities and rights in the fund. And one important point is that all the profit that the university will get from all these activities will be shared equally based on the university rules with the university's research, between the university and the researchers. So we spoke about our collaborations, our funds. Let's talk about technologies. So it will be just in a nutshell. I want still the focus from our researchers that will wait for you after we finish. But let's just get a taste of it. So we have many technologies in life sciences, starting from parts of it, that it's triggering cancer self-destruction. Part of the problem in cancer is that the cells are losing its ability to die, called apoptosis. What Professor Sarit Larish has found in her great research is that arts can return to these cells the ability to apoptose, to die. So Sarit Larish and her team have identified 5 lead molecules that mimic the operation of arts, and by that can really change this phenomena of cells that can't die. Second company and technology is Rescue Pharma, based on the great research and innovation and invention by Dr. Dalit Barkan and Dr. Amira Mariel. You will hear them following me. As you know, recurrence of cancer is a huge problem. You might cure the first appearance of the cancer, but then when there is a metastatic disease, that's a major problem. So what the great researchers have identified is that fibrosis is really a very significant part in the mechanism of formation of metastatic cancer. So, and then they saw that it has to do with the breakout of these recurrent cells of cancer has to do with the fibrotic niche. So now it's about changing the fibrotic niche to avoid the breakout of the dormant cells. And this image is better than 1,000 words. You can see here, amazingly, how the metastatic breast cancer looks without the treatment developed by the team, very bad, and how it looks with and after the treatment. I think it's amazing. Memodero is developing a new, it's based on Dr. Rafi Lemprecht's project and research, and it's a new drug for fear and anxiety disorders, PTSD. Major issue, major problem. What the team has identified is that ephedrine A4 has a very significant role in impairing long-term fear memory formation. So now they are looking to find mimetics for it, and we invested from Carmel Innovations, and hopefully they will get there. MemoBoost. I'm very sorry that Mr. Professor Eddie Barkai is not with us today. His mother passed away, and we are sending our condolences to Eddie and his family. Eddie and his team have developed a great development connected to cognitive and learning enhancement. It's not just for elderly people, it can be also for young kids. So they have identified a receptor that whenever it's blocked, animals are not able to learn rules. They cannot learn how to learn. And on the other side, when we overexpress the receptor, it improves their learning. So this was life sciences. We have many technologies in agriculture, one of which is drought tolerance research, led by Professor Zion Fahima and his team, who have identified genes that are potentially improving drought resistance. Marine innovation technologies, as I said, one of the best in Israel. And there we have technologies that are related to geophysical mapping and imaging, to advanced analysis of seafloor core samples, and others. We have a very strong underwater acoustic lab that can provide services and has new innovations. Many technologies in marine biology, microbiology, biotechnologies, pharmaceuticals that can be part of it. And one of the exciting projects is a research by Dr. Tali Treivitz. She will be here outside after our presentation. And it has to do with intelligent cameras in scattering media. So the underwater visibility and at the same time the visibility in haze above Earth are very challenging. And it's challenging because the visibility is bad, because of loss of contrast and colors, and so on. And what Tali has developed in her research is very sophisticated algorithms that automatically increase the visibility, enhance the contrast, and recovers colors. You may see here an example. It's very trivial how significant this change is. Underwater and on Earth. More images, and this technology is patented by us. You can see the difference between the input images and the results of Tali and her team. More examples. You can see here how this technology works with artificial illumination as well. And the potential applications for this technology are enormous. It starts from autonomous car in bad weather. We all know how exciting autonomous car became recently. Everyone is talking about it. We have many projects around it. This is a very significant part of enabling the autonomous car driving in bad conditions. Underwater inspection and construction, gas and oil, another huge area, fish farms, defense, and so on. So we have many potential customers for this technology. The defense industries are already working closely with, okay, Michael is showing me the time. I'll do it fast. I'll jump to information technologies. So here we have a very large variety of technologies ranging from intelligent user interface, user modeling, recommended systems, human-computer interaction, computer vision. This is really exciting. It's about image matching, medical imaging applications like analysis of biopsies and colons for, or applications for colon cancer, analysis of human motion from 3D data, mobile robot navigation, another growing area. And last technology, for you, Michael, is data reduction using Corsets. And this is really exciting. The technology that Dr. Danny Feldman and his team developed is about semantic compression of data sets into smaller sets. It can be used for solving machine learning problems in parallel or in real time. What it enables is many various applications, one of which is drone navigation. And in fact, if you will visit the Grand Canyon, at least the Grand Canyon in Haifa, we are not there yet, you will see that our drones are flying over, still in a cage, to be on the safe side, but the technology is already working. So it's about processing with very smart algorithms, huge amounts of data, selecting the right data so that we can process it on time, and the drones can lead and navigate people in the mall or anywhere else. So I couldn't have done all that without my great board of directors. My chairman, Doron Birger, the president, Ron Rubin, Mr. Giora Shalgi, Professor Itzhaki, who is my partner in the day-to-day work, Mr. Dan Vilensky, and Mr. Ilan Meshulam. Thank you. And then, last but certainly not least, my great team. That's the whole team. It's small, but very effective, and they are responsible for all of it, for the success, for the hard work, and it's just the beginning, because the sky is the limit. Thank you. And with that, I would like to invite Professor Fouad Fares, who heads the Laboratory of Molecular Genetics at the Department of Biology. Fouad Fares, my friend, co-founded a hugely successful biotech company called Prolo, that I'm sure you all know, and is a member of the Israeli Council of Higher Education. Amongst many projects that he's leading and inventing, he's now working on new ways to treat colon cancer with medicinal plant extracts. So Fouad, please. אתה צריך את זה? את זה אתה צריך?
Good morning. So I would be glad to be here in order to represent actually the main project that is going on in our lab. So we are concentrated in natural products for treatment of cancer. So the main project in our lab is concentrated in treatment of cancer. So we are going here through two main directions. One direction is actually to study the silencing genes that they are not produced in cancer cells, and we are in the way in order to identify some of them, clone them, and then transfect them into cancer cells in order to induce cell death, and this way actually for gene therapy strategy. And the other way is studying natural products that they are coming from medicinal plants and medicinal mushrooms. I will concentrate in medicinal mushrooms, and I will briefly give you some results for medicinal plants and where we are and what our plan for the future in these studies. So we all know that medicinal plants and medicinal mushrooms, they are the most important source of drugs. And actually, if we talk about chemotherapy for treatment of cancer, the main drug is Taxol, is coming from one of the plants in the north side of America. So I will give you briefly the results for in the project of medicinal mushrooms. And for this project, actually, we set up the CanCurex company, leading by Carmel Innovation here in the university. The main team in this project is myself, Professor Solomon Wasser. I will talk about him in a minute. Dr. Lital Sharvit, Dr. Nail Azam, and Dr. Renat Bar Shalom, that they are leading the experiments in our lab in this project. So a few words about myself. I finalized my MSc and my DSc in the Technion Institute, Medical in Faculty of Medicine. Then I moved to as a postdoc for Department of Molecular Biology and Pharmacology at Washington University, St. Louis. Then I came back to Israel and I set up the lab for molecular genetics in Carmel Medical Center that it's now gives the genetic counseling for genetic diseases actually in our community. Then I will be proud also to represent that I am behind the Elomva. Elomva, this is FSH long-acting. It's used worldwide right now for in vitro fertilization, and it's led by Merck in Germany. Then I set up the company called Prolor Biotech. It's all for designing a long-acting recombinant proteins. And the company was a public company in 2007 at NASDAQ and Tel Aviv Stock Exchange. In 2013, it has an exit to Opco Health in USA, leading by Dr. Phil Frost. In the mushroom product, we have a very nice collaboration with Professor Solomon Wasser. Actually, he's a worldwide leader in the study of medicinal mushrooms. He's the editor-in-chief of the International Journal of Medicine and Mushrooms. He has a lot of patents in this area and advisory board member of several biotech companies. So the strategy in this study, actually, we took the mushrooms that Professor Solomon grow in his lab. We prepare some extracts, and we test these extracts in the viability of cancer cells in the lab. So this is the line that we are going through, actually extracts from the, sorry. So we prepare the extracts, and when we test these extracts in the bioactivity using in vitro and in vivo models in the lab, we select the most active extracts and then went to fractionation studies in order to purify the active fraction. And in CanCurex, we are here right now. We identified already one molecule, small molecule, coming from the extract, and we are in the phase of synthesis and then lead the synthesis for bioactivity in vitro and in vivo and lead it to clinical studies in human. So briefly, very few results in this regard. In vitro studies, we use different cancer cells, pancreatic cancer cells, colon cancer cells, breast, prostate, head and neck cancer. And in all of these cancers, it's very interestingly that the extracts reduced cell viability and induced cell death, which we call it apoptosis. And in order to understand the mechanism of action of these extracts. Actually, we tested the effect of these extracts on gene expression in the cells, and we came out with this scheme that we know right now which genes we are expressed in the cells following the treatment, activating caspases, this is enzymes that induce actually cell death. In vivo studies, we use this model of node mice. We inject the cells under the skin, and when we induce the tumors in the animals, actually we treat the animals with injections. In this study, we injected IV to the mice. We can see here that the tumors are stopped growing, and in the control animals, the tumors are continue to grow. And interestingly, that this treatment is safe for the animals. There is no change in the body weight, no change in the kidney and the liver functions. So we believe that this extract is safe for use. And if we look at the tumors after the experiment, we can see here the tumors from the control and the tumors from the treated animals. And even some animals, the tumors are disappeared following the treatment. So then we went for extraction fractionation in order to identify the chemical structure of the active compound. We are here right now. We identify one peak, that behind this one peak, there is only one molecule. And we are already know it's a small molecule. We know the molecular formula. And now we are in the phase of synthesis of this molecule in order to lead it for clinical studies in human. So this is our future studies. We would like to synthesize the derivatives of this molecule and lead it actually in the end for clinical studies in human. A few slides only for the project of medicinal plants. We used medicinal plants that it's well known as antioxidant plants. We tested here in colorectal cancer, in vitro and in vivo. This is the model that we use in this study. We can see here the tumors in the control cells and the tumors in the treated cells. And even we have ultrasound of the tumors inside the animals when the animal is still alive. We can see that the tumors following treatment actually disappeared after treatment. So it's very promising projects that we would like to lead it further for fractionation studies and also to identify the active molecule and lead it as the project of the medicinal mushrooms. So CanCurix is funded by Carmel Innovation, as I mentioned before, and in order to proceed actually for synthesis and for clinical studies, we need additional funding. So here, thank you for your attention. Thank you very much.
Thank you so much, Fuad. Fascinating. And now it's my honor and pleasure to invite Dr. Amiram Ariel and Dr. Dalit Barkan, who will tell you all about Rescue Pharma. So Dr. Amiram Ariel is the chair of the departments of biology, medical sciences, and human biology, and the head of the laboratory for molecular pathways in the resolution of inflammation at the University of Haifa. He is also the vice president and secretary of the Israeli Immunological Society, and together with Dr. Dalit Barkan and Carmel, they have established Rescue, a startup company for isolating anti-fibrotic and anti-metastatic agents to help treat cancer. And Dr. Dalit Barkan is the head of the laboratory of tumor dormancy and metastasis, the Department of Human Biology, and the scientific innovator of Rescue Pharma. Dr. Barkan received several awards, among them the prestigious National Cancer Institution Directors Career Development and the Innovation Award for and the AACR women in cancer research. Dr. Barkan's lab works on breast cancer recurrence. She's developing new treatment to prevent the emergence of dormant metastatic tumor cells from reawakening and establishing metastatic diseases. Galit, thank you.
So thank you. First of all, on behalf of Miriam and myself, I would like to thank Carmel Innovation for their support of our research. Without that, we could not have progressed so nicely with our research. So our company actually established a novel platform for technology for discovering the development of therapies for cancer recurrence and fibrosis. So what we know to date is that the major cause of mortality of breast cancer patients, and not just breast cancer, cancer patients in general, is not due to the initial primary tumor growth, but rather it is due to recurrence of the disease and the progression of the disease to metastatic disease. So when we talk about breast cancer patients, we talk about recurrence that can occur 5 to 20 years post-treatment. And once the disease reoccurs, it can either reoccur at the breast tissue itself, or it can reoccur at distant organs such as lung, bone, liver, and brain, what we call a metastatic disease. So we have breast tumor cells that are circulating in our body and are forming secondary tumor at distant sites. Now, this very long latency in the appearance of the disease is explained clinically by the persistence of these disseminated dormant tumor cells that are not clinically manifested. And what leads to the clinical manifestation years and decades later is still largely unknown. No more troubling are accumulating evidence in the literature demonstrating the presence of these disseminated dormant tumor cells in bone marrow of breast cancer patients, even at a very early stage of tumor progression. We know today that these disseminated dormant tumor cells are actually the source for reoccurrence of the disease. This is also based on animal model system that others and we have developed recently. Here we're seeing a tumor, a primary tumor, a human primary tumor in mice. This is live imaging inside the animal, and you're seeing that the cell actually detached from the primary site. And they reach distant organs such as lymph nodes and the lung, and you see that they lay there as single solitary cells, and these cells are dormant. They're non-dividing cells for months, and after several months, these cells will resume to proliferate and form micro and macrometastatic lesions. So this scheme illustrates the different stages in the dissemination of the cells from the primary site, and once the cells disseminate from the primary site, enter the circulation, they will eventually leave the circulation and colonize a new distant organ, where there the cell will remain dormant as non-dividing cells, and then eventually subset of these cells will resume to proliferate and form micro or macrometastatic lesions. Now going back to these dormant tumor cells, these cells are quiescent, namely they are non-dividing cells, and therefore they are refractory to any conventional treatments that are out there in the market, namely ionizing radiation, chemotherapy, biological treatments that are all aimed on targeting cells that are proliferating in an exponential manner. Also, unfortunately, we do not have any imaging moieties that can enable us to detect these cells in the patient. So they are sitting there like a ticking bomb, and we know that they are the source for the occurrence of the disease. And therefore, it is vital to develop new strategies and new approaches to prevent this emergence, this reawakening of the dormant tumor cells to metastatic growth. So the major question is what actually takes a dormant cell and evokes its reawakening? So several years ago, we discovered that what actually awakes those dormant tumor cells is the changes that occur in the microenvironment, or let's say in the tissue where there's tumor cells reside. And these changes actually resembled a scarred tissue. And this, upon establishing this scar tissue, the dormant tumor cells will start to proliferate and form micro and macrometastatic lesions. So if we want to simplify this, we can envision that the dormant tumor cell is like a seed that needs this fertile soil, which will be the fibrotic lung in this case, in order to thrive. And therefore, we hypothesized that maybe by preventing the formation of this fibrotic-like niche, we can prevent the outgrowth of the dormant tumor cells, and the dormant cells will lay dormant. So this is actually a different approach in oncology. Our idea is actually not to kill the cells, not to shrink the tumor. We are tackling those cells, the dormant cells that we awaken are responsible for the mortality. And we are actually suggesting to keeping them dormant, living with them in a chronic situation. So how will we do that? So what we did in our company, we developed unique white blood cells called macrophages, which we coined them as pro-resolving macrophages. And these macrophages are able to secrete bioactive components that prevent the formation of the fibrotic niche and the outgrowth of these dormant tumor cells. So here's an example. Here we're seeing a model system that I developed several years ago that models tumor dormancy and outgrowth outside the living animal. And in this model system, first of all, we wanted to establish a fibrotic microenvironment that is depicted here by this red staining. And you see that upon treatment with these bioactive components that are secreted by the specialized macrophages, there is total abolishment of the formation of this fibrotic environment. Now, when we take this system, and now we introduce the green cells that you're going to see in a minute, these are the dormant breast cancer cells, we ask two questions. First of all, will they outbreak in our system once we have a fibrotic microenvironment? We have actually shown this previously in vivo, and we wanted to recapitulate it in our model system outside the living animal. And we wanted to see if indeed by treating them with these bioactive components secreted by the specialized macrophages, they will remain dormant. And indeed, this is the case. So here are the dormant cells. This is 2 weeks after we culture them. They actually form these clusters, they aggregate together, and they are non-dividing. When we introduce them to the fibrotic microenvironment, in red here, you see that they are outbreaking, but upon treatment with the soluble bioactive components, we see that there's no formation of the fibrotic niche, and the cells actually remain dormant. This is a quantification of several repetition of these experiments, and you see that the cells, indeed, upon treatment with these bioactive components, remain dormant. We also have already proof of concept in vivo. So what we did is the following. We took cells that metastasized to the lung and spontaneously transitioned from a dormant state to a metastatic state by forming this fibrotic microenvironment. And we pre-treated them and continue to treat them with these bioactive components. And what you see is quite striking. Even for those of you who are not experts, you can appreciate the dramatic difference between these two images. So on the left-hand side, we're seeing the histology of the lungs before the treatment, and you see massive tumors, massive inflammation, actually fibrosis going on. And this is after treatment with these bioactive components. Actually, we're seeing that the lung looks like it's normalized totally, and we see very few micrometastatic lesions. Here's another image that also Elka shared with you that we are very excited about. Here we actually look for the metastatic potential of the cells, which is depicted here by the green cells. And again, you see very nicely that these are the lungs that were untreated, and upon treatment, you can appreciate the dramatic difference. And actually, what I want to show you, that the majority of the cells actually are dormant, and very few are outbreaking. And those that are actually outbreaking and are proliferating, their volume is threefold lower compared to the controls. So to summarize, we propose here actually a novel approach to treat a recurrence of breast cancer, and actually we envision this will be true for other cancers. And this is by resolving the microenvironment that supports the outgrowth of dormant tumor cells by natural products of the normal healing process. So these macrophages actually participate during the wound healing process in our body, and therefore we expect that these bioactive components will have very little side effects. Now, what is the potential commercialization of our findings? So first of all, we are in the stage where we have already leading bioactive components that we have identified, and we need to validate them and move forward. And actually, at this stage, we are looking for another round of money so we can proceed to maybe succeed and have other companies interested in our project and commercializing it. And what we foresee is the following, that these bioactive fibrotic antimetastatic factors are not just going to be used for breast cancer recurrence, but actually can be used for treatment of other cancers, such as pancreatic cancer and esophageal cancer, which are all characterized by the ability to form this scar tissue. Also, these bioactive components, as I show you, have antifibrotic activity. They prevent scarring, so we can envision to use them in wound care and cosmetics. But also, we can actually maybe use these bioactive components for treatment of other devastating diseases, such as idiotypic pulmonary fibrosis and cirrhosis of the liver. These are devastating diseases that do not have a cure. So that's it. Thank you very much for your attention. And you are welcome to see us in the booth outside.
Thank you, Dalit and Amira. Before I hand it over to Michael, I would like to personally thank Mr. Yariv Sultan and Michael and their teams globally for their excellent help in making all this happen.
Thank you very much, Elka. Most appreciated. And thank you very much also to Dr. Barkan, Dr. Ariel, and Professor Fares. We have heard quite a lot already, but the best people to tell you about their work are the researchers themselves, as you could see here now. If you want to hear about fighting chronic pain, how big data can revolutionize our lives, or new ways of teaching children mathematics, we encourage you to speak to our faculty outside in the exhibition that is there really for you. Go and talk to them. We will reconvene again at 11 for the German Friends reception. New Doctor of Philosophy honoris causa, Dr. Sonia Landstein-Kandel, will be making her keynote address. And we will have a very interesting dialogue on women's empowerment between our new Dean of Students, Professor Jenny Korman, and an amazing woman from Nazareth, Miss Nabila Espagnoli. So after you see the exhibition and you talk to the people, we'll be happy to have you here again. Thank you very much.